Thank you. If you guys can't read this, here's the Wi-Fi. So like the person introducing me said, my name is Cody Lindley. I work for a company called Telerik that's in Bulgaria. They have several offices here in the United States. And I work on a product called Kendo UI, which is jQuery-based JavaScript widgets that can be used in mobile platforms and pretty much anywhere the web platform will go. You can find out all you want to know about me at my website, codylindley.com. And you can actually follow along with me as I give this presentation at this URL. There's a lot of links in my slides, so those people writing notes, you can just visit this URL and all the notes are sort of there, or you can follow along. So I'll give you guys, anybody who wants a chance to go there now. Okay. So I'm here today to talk about planning a front-end JavaScript application. But before I do that, I think there are some things you need to know. I think you need to know what type of developer I am. And I think you need to know what type of JavaScript app I'm talking about in this presentation. You'll have to excuse me. I feel like I caught a little cold on the flight over here, so my voice might go in and out. I'm a front-end developer, which means that I sling HTML, CSS, and JavaScript. But more importantly, I think it's critical you know what I'm not. I'm not an all-in-one developer. Now, I made this term up, so I'm going to unpack it a little bit. I am not a developer that uses an integrated development environment. I don't use studios. I don't want my repository and my IDE and my bug system and everything, and my application framework. I don't want it all delivered to me in one solution. It's not the type of developer I am. Some people like print, scan, fax machines, and I'm not trying to be negative towards them, but that's not the type of developer I am. If I want to change or upgrade my printer, I don't want to have to upgrade my fax machine. But there are all-in-one developers. I'm just not an all-in-one developer, and most front-end engineers aren't. I'm not a full-stack developer. Does everybody know what that term means? Is that a pretty common term? I'm a front-end engineer, which means I write all the code that gets sent to the client. As front-end engineers, I don't write back-end code. I don't write API code. I don't consider myself a front-end, or I don't consider myself a full-stack developer. And I'm not a reinvent the wheel developer. Now that's probably pretty obvious what I mean by that, but I'm still going to unpack that a little bit. There are a lot of services available today that make being an engineer really simple. And a lot of engineers want to recreate everything, and sometimes they come up with really good reasons to do so. But at the end of the day, if you can spend $5 or $10 or $15 on a service, and it does a job for you, then that's probably a good choice, especially if they have all the domain knowledge and they can provide that service to you at a really high degree of success. So, what type of JavaScript app am I talking about? I'm talking about a single-page application. Who here has built a single-page application? Great. Talking about an API-driven app, a back-end and a front-end that are probably decoupled. The app is driven by an API. It's a data API. It's more than likely an unhosted app, which means that the data API or the backend isn't necessarily on the same host that the application is running. And in fact, the front end might be completely static. It might not matter where that front end is. And it's more than likely the type of app I'm talking about is built by a team of developers. I think, I'm sure most of you here have probably built an app solo, and we probably would do things a lot different than we do if we were working with a team of developers. So this is the type of JavaScript app I'm talking about. And I'm really trying to give you guys an understanding of my perspective and the context in which I'm speaking, so you guys don't give me this look during the presentation or after. Okay, so back to planning a front-end application. We're going to talk about this in 16 steps. That sounds like a lot, but if you're a front-end engineer, I think you can handle it. That's why we get paid a lot of money. If you're a full-stack engineer, this would probably be like 50 steps. So step one, I gave this presentation like a week ago, and I asked people what they thought the first step in planning a front-end application would be, and somebody guessed it. I was kind of surprised. So I'm going to open this up a little bit. Does anybody think they know what the first step in planning a front-end application would be? Make a plan. I like it. A little generic, a little more specific. Find a problem. Still a little generic. If you're going to build an application, necessarily not even a front-end application, what is the most critical thing that you do from a planning perspective when you build that app? That's sort of, okay, sure. That's not it, but know your user. So user-centered design, I think that's a truism. I agree with it, but it's always true. Like, we're building everything for users in this space, so totally agree. Anybody else want to take a, yeah? Sure, I'm glad you said that. That's not it, but that's where a lot of people start, right? Which makes sense. But again, we're building an API-driven application. Yeah. Yeah, so I'll take that. The first step in building an application is verifying you have a working and stable API. Now, what's presumed in this is this concept of API-first development. Has anybody ever heard of this? Yeah, some people. This is after, so I've been doing this about 15 years. This makes perfect sense, that if you're going to build an app, that you should build the API first. If you're not familiar with this, it means that you document, build, and test your API. Before you wireframe, before you write a line of application code, you should have a stable API. This is the perfect time as front-end engineers to be prototyping, creating minimal viable products and features, and helping the API engineers test their API. You want the language of the API to be completed and done. And here's the reason. I'm assuming some of you have worked on an app where the API was a complete mess, or even a little bit of a mess. But each imperfection in that API will get absorbed in your data layer in the application, and it will be amplified to a horrible degree. This is probably my biggest nemesis when I build apps, is poorly written APIs. Even API engineers who think they've written something great, and then we walk 6 months with it, and we've destroyed our data layer in the app. This is really important. I should mention, as a front-end engineer and not a full-stack engineer, I rely on the API developers to provide security and authentication through that API. Right? We need a user to be able to be authenticated and CRUD, create, right, data, and it's typically taken care of in this step. There's also typically a developer's API, which is not a production API, right? So if you go out and build an API, you don't build one API, you sort of duplicate it, and that's what you use during development, and then there's a production API. A lot of people don't do this, which shocks me. But I'm curious, has anybody ever thought about API-first development? Somebody comes to you and says, I want an app, and you don't say to them, here, let me wireframe it. You say, let's work on your services, let's work on your data API, and let's make sure it's right. So that's step one. Step two, again, very surprised how few people think about these choices and these steps. And some of these might seem really simple to you guys, but I'm surprised how many projects I come on, and this isn't done. So you're going to need a ticketing system, a version control system, a document storage and team communication system, and some sort of task management system. And you usually want to pick these up front Because as soon as you start collaborating with somebody, you want to document it. So here are possible solutions, and some of these might be familiar. I'm hoping GitHub is. I do have a laser. Slack, has anybody used Slack here? Awesome. If you have not, this is a team communication tool. It's sort of like Skype, but you can store documents in it, and the search actually works. It's really great. Concept board is something I use with interaction designers and visual designers. It's the first tool I've found that I can store static images, and we can collaborate on them. Because you can essentially draw over the top of it, add comments, and have a long dialogue about a particular something in a static image. It's really great. And Trello, I'm sure everybody heard of that. It's a Scrum board. It's just a task board. But at least you need these things to get started. Step 3. The first 3 steps, I'm still amazed at how few people think about these things or do these things, but we need to create a foundational specification. And that means which devices will your app run in, what's the minimum resolution, what operating systems are you going to support, which browser are you going to support, what languages. This is a big one. A lot of people cast this aside. What cultures? Will it run offline? This is the future. Everybody should be thinking about offline apps, especially as we start making everything connected to the internet. Which accessibility standards are you going to support? What's your SEO strategy? These 7 things are the most critical things you do in a web platform app, in my opinion. I can't think of any other decisions that have such a far-reaching tentacles into your app than these. These are 7. Does anybody think I've missed one? Is anybody passionate about something I missed here? What's that? Analytics, monitoring. I don't know if I would put that in specification. It's definitely in one of my steps, but I agree, like, this is part of a foolproof app as analytics. It's true. Anybody else? Yeah. It's sort of presumed. I mean, in order to answer the question of globalization, you have to decide who you're targeting. Yeah. Yeah, I think it's probably fair to say that I believe in user-centered development. Like, I'm not somebody who does user-centered research, but we should just presume that's the case. Okay. So here are possible answers. This is a pretty simple step. I hope everybody does this when they build an app to some degree. Step 4, select a software development process. Now, in 15 years, I've done a lot of different development processes. Done a little old school, which is this, in my modern agile brain, this really is hard for me to swallow today, even though we did this for a long time. You'd plan something, you'd build something, you'd test it, and then you'd deploy it. And you do it one time. And that's a great idea, because humans are great at doing things one time. That's sarcasm. It's a horrible idea. I've tried RAD. I've tried extreme programming methodologies. I've tried Scrum. I've tried, and I'm guessing most of you are somewhere in here, this agile-ish type thing where you adopt some agile methodology and you kind of scale it back to your needs. I've tried that. And I think at the end of the day, you just have to pick one that works for you. Now, all the ones I have spoken about have always left me feeling exactly like this. And I've not heard different. There are some pretty hardcore Scrum people that believe that methodology works, and I'm not trying to belittle that, but in my experience, this is what works. This is what we've been doing for a couple years. And it's pretty simple. We meet Monday morning, we prioritize dev tasks, we pick tasks that we can accomplish in a week because a 2-day contextual switch is bad for you. I hope every programmer in this room knows contextual switches are horrible. This is sort of why week sprint makes a lot of sense. And then we meet Tuesday through Friday, and we try to keep our meetings small, but we talk if we need to talk. We sort of discuss what we're doing if we have any blockers. We simply communicate with who we need to communicate. There's so many methodologies out there that are pretty stringent about how you communicate and when you communicate that that itself has become a blocker. And we iterate until it's right, and then we release it. Now, that's pretty idealistic, I know. But in my experience, somebody asking me for a date, I can give them what I call a wild-ass guess. And I typically do. I'll give them a wild-ass guess, but then I'll just go back to this concept of iterating until I get it right. And that's usually, at the end of the day, what happens. Anybody else experience this? Or are people happy with their methodologies, software development methodologies? Is anybody like gung-ho? Raise your hand if you love your methodology. Come talk to me. I'd love to hear about that. Step 5, select platform and hosting service. Now, I'm a front-end engineer, so of course I'd probably pick something that's JavaScript-based, like Node.js and Modulus as the host. This is pretty simple selection, but important to do up front. Select package managers. Now, because we selected Node, we'd probably take NPM. And because I'm building a front-end JavaScript app, I'd use Bower. Everybody use Bower here that builds front-end apps? Is anybody jumped on the I hate Bower train lately? Come talk to me. I'd love to hear why. Step 7, select site and user analytics, which is really important. I'm amazed at how many people do overlook this step. And you might choose something like Chartbeat or Mixpanel. And I put in here, use Segment.io to install. Has anybody used Segment? This tool is brilliant when planning a front-end application, in my opinion. And it's because I hate littering my application code with a bunch of third-party code. And so what I want is one library in my application code that allows me to turn on all the third-party application code I want to use for all sorts of different reasons. And this is kind of what the UI looks like. You put in segments code, and then you can flip on and off all these third-party services. And it's pretty much one line of JavaScript instead of 20 or 30 third-party lines of JavaScript that wreak havoc all over your app. It's really great. So step 8, select code and style enforcement. I'm assuming a lot of you guys use these. CSS lint, HTML hint, JS hint, JSCS. Has anybody used JSCS yet? Awesome. So the ones in the column closest to me are somewhat stylistic, but they link to your code. They tell you if there's errors in these particular languages. They also help you guide some of your developers on how to write them. But the last one's pure style. It's pure style that basically forces style upon your developers, which they might like or might not like. But it's really great if you want all your code to look the same and you're working with 10 developers. You should be thinking about these when you're building a front-end app, definitely. Select a task runner. Now, we're on a Node.js platform, so obviously we're probably going to pick some sort of JavaScript build tool. You could take Gulp and plugins. So these tools, to me, is what brought front-end engineering into a respectable engineering space, is the fact that you can essentially do everything you need to do locally to build and test and deploy your app all on your local machine because of tools like this. And I think I give that its grandeur because it's now in JavaScript. And if I've been a front-end engineer for 15 years, I've never written another language besides JavaScript. So as soon as all these tools became available in JavaScript, a whole nother world opened up to me, at least, as an engineer. Select an application architecture and structure. Now, when you go to front-end conferences or you go to most engineering conferences, this one step is where the majority of people are spending their time talking about and thinking about. And probably with good reason, but we might have overcomplicated this space a little bit because for a couple years now, there's really good solutions out there. And everybody sort of puts this together differently. And the one thing up there that I think most people underestimate is app structure. Some JavaScript frameworks prescribe a structure, and some of them require you to create your own structure. And this is where most front-end engineers get stuck, because they don't know how to structure an app. And so you could probably start with something like AngularJS and ngSeed and UI router. And then, of course, because you're building a modular, small application that really is built up to a big application, you need some sort of dependency type injection or management. And I put Kendo UI in here. I worked for Telerik, but I actually used Kendo UI for years building apps. It's the one I still recommend. But this is a critical step. I mean, you could spend years learning these things, but I really do think that you've just got to pick one, use it for a year, build an app, and move on to the next thing, because in a year there will probably be another thing. I think it's more important you understand your needs than you understand the solutions. Select testing methodologies and tools. You're going to need a test runner, you're going to need a test framework, you're going to need assertions, you're going to need mocking, and you probably are going to need functional testing. Now, I'm sure you'll recognize some of these solutions. Karma, which goes along with AngularJS, Mocha Chai, Sign-On. And that's Mocha's test framework, Chai's assertions library, Sign-On JSON JS is mocking. And this is all focused around doing unit testing. But does anybody love doing unit testing in front-end apps? Yeah, oh, interesting. Do you guys love doing functional testing? Yeah? So this has been my experience with apps. Unit testing only takes us so far. And it's functional testing that I actually enjoy the most and I feel like I get the most out of. And there's some great tools to do functional testing to me today. You know, the fact that from my build system, Gulp.js, I can spin up browser stack and I can automate a user using something like Nightwatch.js, and I can completely write a test as a user that uses the app, because those are the errors I actually care about. Unit testing a front-end app is really good at a micro level when you're testing a module and you want to understand, does that module do what it's supposed to do? But honestly, the bugs I see in an app come from QA that's actually using the app. And I can negate those through functional testing better than I can unit testing. I'd love to hear if people have different experience in that. Code complexity. Who here uses a code complexity analysis tool? Anyone? Cool. So not super popular. The one that I've used is called Plato. It's based on complexity report. If you've never used one of these tools, we're going to check out the Wi-Fi here. So this is a source analysis of jQuery. And we've got source lines of code, average maintainability. This is for all the modules in the library. And this is the Plato interface. So if we go down here and we pick a popular, let's pick the Ajax. We've got 855 lines of code in that one module. And this complexity tool helps us understand how each module, the maintainability of it, how complex it is, what the paths of a function through that code is. And a great tool to reject code from developers. I've actually set this up to reject code from developers, where I said your threshold of complexity is too high. Your number of lines of code is too much. You need to break it up. This is a great tool. I'm surprised more people aren't using this tool. Now it's probably not going to let me go back. There we go. Use this tool. Make me happy. Use this tool. Define deployment strategy. I actually don't think there's enough talk about this going on right now, and maybe because it's such a new concept to front-end engineers. But using some sort of continuous integration server to take your local environment, which is a standalone build, test, deploy environment, because you've got all these JavaScript tools now, you can do this locally. But you should probably plan out what you're going to do with this local environment. You've got your development data API, which you're probably using locally. But as soon as you push more than likely master, not a branch you're working in because you're working in team, to GitHub, that whole environment can be pushed automatically to a continuous integration environment. And that is where it automates all of your unit tests, your functional tests, your all the performance things you just heard about, all the minification. And this thing can automate pushing or deploying to staging in different environments depending upon your strategy. You should be thinking about this and planning these. All these things, in my opinion, can be thought of before you write a line of code. I love this tool. It's not super popular, but has anybody used Gymnasium? Is there a Ruby developer in the room? You ever heard of Gymnasium? This tool is awesome. If you manage a lot of package managing configuration files, you know, your Bower configuration file or your NPM file, you have to literally open it up and look at the version numbers of all your dependencies. And you have to think about each one and go out and learn about them and decide if you're going to upgrade those packages. This thing basically monitors all of your packages, and it tells you if there's potential conflicts, if there's issues, if you should upgrade a package. It monitors all of your dependencies, your package dependencies. It's a great tool. This is part of monitoring your app, which is critical. JavaScript error monitoring. Anybody do this? Anybody do it homegrown? No. This is another tool. I've had to fight engineers to get this in a project, which blows my mind. You have all of your logic is in a JavaScript app, a single page app running in a client, and you want to collect all the errors that occur. If you have built a single page app and you deployed it into production and you're not monitoring the errors, JavaScript errors, you're doing it wrong. You need some sort of tool that will capture every JavaScript error, give you a stack trace, will give you the browsers that the error occurred in, and will tell you about it. You don't need your QA team or anybody else or a user to tell you about this. This tool should be telling you about it. Performance monitoring. And some of these, just so you guys know, a lot of these tools are free to a certain degree. Pingdom, anybody use this? Great. So you write a front-end app and you want to know if it's available or the performance of it, this tool will monitor all that for free and it'll tell you when something's not right. This should be part of planning a front-end app. Now, that was 16 steps. What's that? We didn't write a line of code yet. All we've done is plan. You know, one of the biggest mistakes I think I see developers make is they never know what they're aiming at. And the successful developers always know what they're aiming at. They always know where they want to throw a dart. So why follow these steps? Like, what is if you could take one thing away from this presentation, it might be this, it might be something else I'm going to say, but Why follow these steps? What is the point of planning and thinking about and architecting an application? Why do you do it? He said eliminate waste. What? Let's. Sure. Sure. I'm going to presume all user-centeredness. But you're an engineer. Your mind is about what? Why do you build an app? Doesn't even have to be a front-end app. What is the point in being efficient, thinking about architecture, thinking about tools? Why do it? Anyone? I feel like a professor up here. Anyone? This is why we do it. The entire point of building an application is to build it to last. That's it. If it's built to last, that probably means it's documented, it's modular, it's tested, it's monitored. I didn't just make this up. This has been in software development for a long time. When you're thinking about all these things and you're going through the pain, this is it. You want to build an app to last. That's why you unit test. That's why you want the best JavaScript framework. That's why you want to hire the best engineers. This is what you're aiming at. So takeaways. I think it would be easy to take away from my talk all of these tools I just told you guys about. But that's not the point of this talk. I added the examples so that you have a context for the categories of decisions I'm talking about in each step. If you want to get something out of this talk, go back through the slides, look at each step, think about the category of decisions that you need to make when you're building an app, and then maybe use the examples as context to what I'm talking about. Because I think there's a lot of front-end engineers in here, could be guessing, that have no idea about half the things I talked about. And my goal here is to try to get you to think about those things. And the examples, some of them I wouldn't, if you came and asked me, I wouldn't even recommend. It's not something I would prescribe. But it's the problem they're solving that I care about, that you should be thinking about. 16 steps. Think about the category of decisions made in each step. Use the examples as context to what I'm talking about. If you're interested in API first, there's some content about this. If I could prescribe one thing about building applications, make sure the data API is right. You will love your job, your life, and the people you work with if this is done right. Not a whole lot of people are talking about how to build JavaScript apps. In fact, this is, when I say JavaScript apps, I'm not talking about what sort of application structure and what sort of framework you're using for application layer logic. I mean, those are going to come and go. I'm talking about these 16 steps and what it's like to be an engineer in a front-end app. There's not a whole lot of people talking about it. I recommend if you want homework or you want to learn more, they're up there. And that's it. That's what I came here to say today. Now, I have to say this really quickly because my employer paid for my hotel and paid for my trip here. But Telerik offers some amazing tools for engineers. We have a mobile platform that is really amazing. And of course, we have Kendo UI, JavaScript widgets. Do me a favor, go check them out, sign up for a free trial. Part of Kendo UI is free open source. As a way of saying thank you for me being here, it would be great if you guys did that. And hopefully, if I planned it right, I wanted to leave time for questions because I'm hoping there are some, or somebody wants to tell me I'm wrong, I would like that. That is most often the case. So I agree that there is a barrier there that's very common. But the idea of solidifying your API as you're writing logic that you want to go into production is insane. That's insane. I mean, if you want your application code to last and you don't want to spend a lot of money refactoring it, convincing people, and sometimes you have to walk this road with whoever you're with. You have to be like, we did it this way, we tried to do this at the same time, and now we're refactoring the code and we're ripping it out. Or we're completely changing the API. There are things that seep into your data layers in your app from your API. I mean, this is why there's a whole movement of API first that's very passionate, because they've been through enough apps where the API was not really cemented enough to be built upon. The other reason I really like this, and I think a convincing thing, is I think because of the tools have gotten so great and the engineers have gotten so great, we can iterate quicker. So this is the perfect time to create minimal viable features. Like, this is where you should be convincing the powers that be, let's iterate really quickly on a feature here or some aspect of it. And maybe I'm going to dump all this code because it has all this old API logic in it. But we need a stable API. I've been on those. I've been on it when we've written the application, we used dummy data and wrote the API afterwards. Then we just rewrote the app, essentially. So I'm willing, I admit, it's what you're saying is the common case. Yeah. Mm. Sure. That is why I'm recommending prototyping. That is why I'm recommending your front-end engineer should be engaged prototyping features, not so that they're helping themselves with the application logic, but they're also providing feedback to the API engineers and saying to them, that's not going to work. That particular way, verbiage you use or theory you have on that URL, depending upon what sort of data layer you have, or API layer, that should all be happening up front. It costs less there than it costs when you tell an engineer, I want you to write this, it's going to go into production, but we might find all these minefields and redo it. You don't want to do that when you're in the flow of writing an app. But it happens. I mean, this is how a lot of people develop today. So that's true. Yeah. So my recommendation is to understand broadly the categories of decisions. That if you might not understand what continuous integration is, and you might not be able to implement it into your app without a great amount of effort and time, but at least you can understand the puzzle piece and why it's there. So that when you do, wherever you decide to dive in, you do understand that there is another puzzle piece out there. I'm trying to alleviate engineers that get really narrowly focused on something like, I'm an Angular developer, and all I know is Angular, and all I use are Angular things, and that's all there is to front-end engineering, and that's not the case. Like, we're maturing. There's conferences about DevOps and all sorts of things these days, and these things matter too, sort of what I'm saying. So be aware, I would say be aware of them. That's why I tailored this talk in this way, and why I said don't focus on all these solutions and being able to implement them. They're just examples to give you context. Learn the context. Learn the category of decision in each step. And then jump in where you want. That'd be my advice.
You have a list of strategies of where we might fit into the list for moderate performance, but not like back-end performance, like more front-end, just speed stuff, I guess kind of relating to what the first talk was about.
Sure, pinged them.
Well, I mean, when you use actually on the page, not as the page is up, like front-end performance. I don't know if
You mean from a hosting perspective or user perspective? So there's all sorts of user analytics tools that are, how fast does this user move from this point to this point and what's going on? I mean, there is a website out there, and last time I was here I talked about. It's called Lean Stack. Has anybody heard of Lean Stack? This is a great solution. You can go in and you can look at major companies and their stacks. And if you go, I think they renamed the domain. Does anybody know what they renamed it to? Share something, Share Stack or something like that. But I forward you if you go to Lean Stack. You will find every monitoring, performance, analytic tool in the world, and you will find the companies that are using it and how they fit it all together there. It's a really great resource. I think I'm out of time. Yeah, do I have time for one more question? Thanks, guys. Appreciate it.